In this video, we're going to come up with the parametric equations for particles starting in a weird place at a weird time. So let's say this particle is traveling along this path. It must travel along this path, and it starts at 2, 4 at time equals 0. So we know that when you have this, it will give us this parabola. But the trick to doing this is to, well, if this is number 2. If you put the number 2 into here, it will jump to here. So we want to align our time. We want to get our time to align with this 2. This 2 here is along the x-axis. But we want our time to align with this 2. So if we start out as t plus 2, comma, and then so when time equals 0, if you add 2, it will jump to here straight away. So you start out with t with this. Hang on, t plus 2. So when time equals 0, it will immediately jump to here, and then all you need to do is put this into this t here. So that will then be t plus 2 squared. So your parametric equations will be x equals t plus 2, and then your y will be t plus 2 squared. So well, let me give you a more challenging one, a more challenging example. So let's say you've got a straight line here. The particle is starting in the middle of nowhere, 2, 2 at time 3. So the trick is to well, at the moment this 2 is along the x-axis. If you put the 2 into this equation, it will jump straight to here. So the trick is to align the t up to this 2 here. So for example, let's imagine t equals 0. Let's imagine our t to be here. One increment of time, it will jump to 1 on the x-axis. To another second later, it will jump to here. But the thing is, we want it so that when time equals 3, it will be here. So the point here is that imagine your t to be here. So t minus 1. Imagine your t to be here. 1 second later, it will be here. And another second later, it will be here. So that's after 2 seconds. After 3 seconds, it will be here. It will line up with this too. So imagine hang on, t equals. So imagine your t to be right here at -1. So imagine this to be so your x location would be t minus 1. So comma. Now if you start your t to be here, after 1 second it will be here, 2 seconds, 3 seconds. So it matches up with this 3 here. The thing is, if you put this into the equation, it will jump straight to here. So all you have to do now is put this into here, so that it will jump right to here. So hang on. So it would be 3, and then t minus 1, and then minus 4. So now all you have to do is tidy this up. The point here is that start your t to be here. So that 1 second later is here, 2 seconds, 3 seconds. So here, after 3 seconds, it will be at the appropriate place. And then all you have to do is put this thing into here, and then it will jump to here. So your your equation will be this. If you tidy this up, it will be 3t minus 3 minus 4, t minus 1, and then tidy this up. So it would be t minus 1, and then 3t minus 7. So x equals hang on, let me think. X equals t minus 1, and then y equals 3t minus 7. Okay, so these are your parametric equations for this particle starting. Well, after 3 seconds it will be here, and it moves here, and it will be the domain of -infinity to infinity. So this is your final answer. Okay.